Master strategies to graph trigonometric functions step by step, showing all the transformations and the critical five key points. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel. We have thousands of videos for you to explore and master these strategies. In this video, we're discussing how do we sketch transform trigonometric functions. We have taken up sine function. So g of x equals to 3 sine half of x minus pi by 6 plus 1 is what we are going to sketch in this particular video. It comes as a request from one of our subscribers who want to understand each and every step of transformation and also see visually how it appears on a graph. So we'll walk you through all these steps. So basic parent function, as you can see, is sine x, right? So we'll begin with sine x, and then we'll look into the period, which is half. So we'll draw the function sine of half x. So once we do this horizontal stretch by a factor of 2, the transformations are known to you, I hope. Then after that, we can do the vertical stretch, which is 3. Let me change the ink because I'm going to sketch each function in a different ink. So it'd be 3 sine half x. Makes sense, right? So that is a vertical stretch by a factor of 3. And at the end, we are going to do the translations, moving it 1 unit up, and then we will translate it pi by 6 to the right. Okay, so then we'll do 3. We can combine the two steps, but let me do it in different ink. Let's have more options here. Okay, so we can have some dotted graphs, right? So what I will do is we'll do this. I'll write this as 3 sine half x plus 1, correct? And lastly, I will finally sketch the final graph in bold red, which will be what we need really, which is 3 sine of half x minus pi by 6. Shifting pi by 6 to the right, plus 1. Is that clear to you? Okay, great. So let's begin with sine x. I took green color for it. So when we do sine x, in that case, we have to look into 5 key points, correct? As you know, the 5 key points for sine x are, it starts with the origin 0, 0, and then at pi by 2, the value is 1. At pi, the value is 0. At 3 pi by 2, the value is minus 1. And at 2 pi, let me write here, 2 pi is back to 0, right? So that is your sine x function, which we are going to look into. Let me put them closer so that we can actually continue with this later on also. So let's write down sine x here. So the 5 key points, as I said, was 0, 0. And then we have pi by 2, 1, pi 0, 3 pi by 2 minus 1, and 2 pi 0. So on this scale, you can see we have 0 here and then 2 pi, correct? So that is 2 pi for us. So we'll divide this into 4 equal parts, which is right there, half and then half of half. Each half represents a quadrant. Pi by 2, you are moving to the next quadrant now from 1 to 2, right? And see how the value moves. So value goes from 0 to 1 to back to 0. Mean you can say x's, right? That would be a good term to use. And there you go. So you have this graph, which is the sine x graph. Makes sense. So we got sine x. Now I will draw sine of half x. Now, when we do sine of half x, the y values remain same, the x values double up. It is horizontal stretch by a factor of 2. So the values will now be, this will remain as 0, 0. But we'll just multiply all x values by 2, right? So this becomes pi but 1, right? 2 pi, 0. This is 3 pi minus 1, and this is 4 pi, double up, right? For each x value. So instead of ending at 2 pi, now the graph ends at 4 pi, correct? Which is right there. So every value stretches right. So now we have a graph where the last point goes to that, the first remains at 0 itself. So it is horizontally stretched as you can see. So instead of pi by 2, the first peak comes at pi. Then the 0, which was at pi, will be at 2 pi. Minus 1 value will move to 3 pi, and we have a graph here which I am drawing in dotted line. So this is horizontally stretched by a factor of 2. Is that clear to you? And you can also see all the points. Third is vertical stretch by a factor of 3. So let's write it down. So we have 3 sine half x. So this time I'm only going to multiply the y values by 3, right? Leaving the x values as such. 0 remains 0, right? So pi 3, get the idea. 2 pi 0, 3 pi minus 3, 4 pi again 0, right? So, so the pink graph which you are seeing, the dotted one, will start with 0 again because we are multiplying the y value which is 0 with 3. But the first value, which is the peak at 1, now becomes 3. So which is right here, right? So 3 times. It's going out of my scale at present, okay? And I mean into the writing which I've done. Zeros will be back to 0 as you can see, right? However, the peaks are going to the extreme, right? So this value also goes to minus 3. So we have a graph which is kind of like this. You see that? You see that? Right. Let me redo this part. It goes to minus 3 back to 4 pi. So we have incorporated the 3 times thing, right? Now we have to shift the whole graph 1 unit up. So let me just change this. 3. Okay, let me write here 3 sine half x. And we are going to add 1 to it. So everything goes up by 1 unit. So you can actually rewrite the points. So this time the y value starts with 1. So you're just adding 1 to the y values. The x value remains same, right? So 3 becomes 4. Very good. So use this information more to get the points. We'll see the sketch of the graph on the next page. Okay, so bear with me. So here will be 2 pi plus 1. We are just adding 1 to each y value, right? X value being same. Minus 3 becomes minus 2 and 0 becomes 1. So the axis changes, and this time the major change which happens is that the axis moves up, right? So all these zeros will now move to this point, which is at 1. Makes sense? And all other points will move up by 1 unit, right? So the peaks will be further up by a unit. You get the whole idea. And the graph will be this one, right? Okay, great. So it looks nice though, right? Because of different colors, I think you can still appreciate it. So we have done up to the translation vertical, and the last one is the final graph when we are going to sketch our function, which also incorporates the translation pi by 6 to the right. Now, in this particular graph, as you may see, Pi by 6 is this much, right? So this is pi by 6. So we are going to just change each point by pi by 6 to the right. You see that? So pi by 6. And we are going to sketch the final graph using this pi by 6, correct? Since it is very messy, I'm not using the red ink now, but I'm using the highlighter, right? Okay, correct. So this, let me now finish it off with the red. So it starts with pi by 6, as you can see, 1, right? This is at 1, and this is at pi by 6. Is that clear to you? And it goes up to this point, then again pi by 6, it comes down and ends up pi by 6 more than 4 pi, correct? Pi by 6 more than 4 pi, which basically means 4 pi plus pi by 6. 6 times 4 is 24. So this point here is 25 pi by 6. Makes sense. So that becomes your new domain for one cycle, right? You can actually repeat this cycle and get your function. Is that clear to you? So this is when you are asked to show each and every transformation along with the points. Right. Now, I'll also show you the second way, which is more efficient to sketch the graph. Okay. So here I'm using second method. So I'm writing this method too. I hope the first method is clear to all of you, right? We actually did step by step transformation, showing you all the coordinate points and how the graph moves. Now, method two, which is a practical way of doing it. So, practically, what we do it is that we actually start with the translation because that is the axis, right? So, we know that the axis for this is y equals to 1, right? So, we'll just sketch this axis 1 first, right? So, this is my axis at y equals to 1. You see that? Now, we look into the amplitude. Amplitude really means that from the axis, you'll go 3 units up and 3 below, right? So 1, 2, 3. So that becomes your maximum, correct? And 3 down, 1, 2, 3. So this becomes your minimum. You agree with me, right? So we know, I'm just drawing the dotted line just to show you that this is the frame under which we are working. So 1, this was 1, 1 plus 3 is 4, and 1 minus 3 is minus 2. So we got our extremes, we got the range of the function. Okay. Now, let's look into the domain of one cycle, right? You understand? Which I am deciding with the time period, which is given from k value of half, right? So we know t is 2 pi by half in this case, which is equals to 4 pi. So 4 pi is where for me? 4 pi is right there. So this becomes one frame. Do you see this 4 pi? Okay, great. Let me write 4 pi here. Make sense? So we have one cycle from 0 to 4 pi. What we are going to do now is divide this into 4 parts, right? So half of 4 pi is 2 pi, correct? So see, I'm just dividing it. I'm just showing you all these things in the video so that it's absolutely clear. And half of 2 pi is pi. It was basically a step where the time period of one cycle is divided into 4 equal parts. If it was t, we are looking at t by 2 and then t by 4. 1 t by 4, 2 t by 4, 3 t by 4. So we got 4 parts representing 4 quadrants. Makes sense, right? We are talking about sine function. Sine function starts from axis. So the sine function is what? It is axis, right? Maximum, axis, minimum, and then axis. Makes sense? So axis and next point maximum, that was a mark point, right? And then back to the axis and then to the minimum, makes sense. And then back to the axis. Does make sense to you? So we basically got this particular graph. Let me join it with green color, right? This graph is much neater than the previous one and is much simpler and faster. Start with the axis, mark the maximum minimum, divide the time period into four equal parts, and then axis maximum, axis minimum, axis. You have a sine graph. Is that clear to you? The last thing which you need to do is to incorporate the phase shift, which is minus pi by 6. Means I have to now shift the graph to pi by 6 right. Correct? So, in our scale, we have this as pi by 2 and this is pi by 6. Two divisions are pi by 6 in this particular graph, right? So, I'm marking pi by 6 units from each key point, correct? So those are my key points which are being joined with the final graph. Make sense? See how neat it is and perfect, correct? So advantage with this method is that we did not calculate the key points transformed. You get the whole idea. We have worked with this concept of axis maximum minimum axis. Hmm? We did not do the calculation which was done earlier for finding x and y final points. But you can see it on the graph that the initial point starts with pi by 6, right? And each value has been added by pi by 6. You do your math, right? And 4 pi plus pi by 6 will give you 25 pi by 6. Makes sense, right? So you have your final graph. This is how you should be sketching any trigonometric function, maybe sine or cosine. If conditions of transformation, show transformation, all those things are not given to you. If the question is sketch the graph, get an idea. Okay. So I hope all this is clear. So for the benefit of our viewers, I messed around the key points. What we've done here is revised uh, how do we calculate the key points, which I did. So basically, what we did was that we started with the x, y, five key points of sine function, which are given here. It starts with 0, goes to maximum 1, back to 0, minus 1, and to 0. The x values are 0, pi by 2, pi, 3 pi by 2, and 2 pi. One cycle of 2 pi. Now, in this particular case, as you can see, it is a transformed function. The x value changes as per parameters given within the argument, that square bracket. So you do the reverse, right? Multiply the x with 2, right? Because of half, and then minus pi by 6 is kind of add pi by 6. So you get your transformed x values, and then for the y values, look at outside. Outside we have 3 and plus 1, right? So 3 times y plus 1, correct? So once I have written these x values, so that is the column transformed x values, and then y values, this is the y values. And I've done all the calculation which I had shown you on the very first screen, final values, right? So it starts with 1 plus 3 means 4, and then back to 1, minus 3 means minus 2 means from 1, right? And then back to the x's, which is 1, correct? So you get all this, and once you do all that, you get a very neat graph showing shown here, right? So the graph in this one is your sine graph, right? So this is your sine x, and this is your g of x, which is shown here, right? Of course, the maximum being 4, right? And the minimum being uh, 1 minus 3, which is minus 2. this is your axis at 1, right? So this is y equals to 1. Makes sense, correct? So so that is how the graph is. We have moved right starting from here, pi by 6, and ending there, which is 25 pi by 6. Of course, it is a periodic function, then you're supposed to extend it as shown here in this particular graph. Sometimes two cycles are required, so accordingly, select a scale so that you can represent both these cycles. So I hope you have understood each and every step clearly. As an exercise, you can actually sketch a cosine function similar to this, and then watch my videos to really understand graphing trigonometric functions or any topic for that matter, right? I hope you find it interesting and useful. Some of you who want to do fast track understanding, they can always contact me on globalmathinstitute@gmail.com. Otherwise, the playlist has excellent videos to learn for free any topic in mathematics for school students. Makes sense, right? Keep watching. This is your channel. Thanks for your valuable time and all the best.